Hi everyone, this is my lesson plan project for ITEC 7430, Internet Tools in the Classroom. This is my roller coaster project that was implemented in my 11th grade physics class. It took 8 days to complete on a 90-minute block schedule. The standards that apply to this lesson include the GSE Physics Standards on Energy, many of the ISTE student standards, as well as literacy standards for writing. The essential questions that were posed during this lesson include: how can the idea of conservation of energy be applied to roller coasters? How do you calculate kinetic energy and gravitational potential energy? How do the amounts of kinetic energy and gravitational potential energy change during the duration of the roller coaster ride? As well as, how does the mass of an object impact its energy? So an overview of the lesson includes students starting off building background knowledge during an initial research web quest where they learned more about different design elements in coasters as well as the different types of energy. Students then furthered their understanding through lecture notes. Then students would complete 2 virtual lab investigations to further investigate the impact of mass on energy, as well as how kinetic and potential energy are connected. And then lastly, the biggest component of this lesson was the roller coaster project, in which students would assume the role of engineers that are pitching a coaster idea to an amusement park company. They would create and analyze a model that then they would submit a pitch to a company that included both a report and an advertisement. Several tech tools were used during this lesson. The main ones were the FET Energy Skate Park Simulator, the Jason Coaster Simulator, Word, and Google Docs. Students were allowed to pick depending on what they wanted to use. And then the Canvas, which is my district's learning management system. The ways in which I used Canvas were mainly to submit student work, which included both their lab reports, their web quest, as well as answers to the online simulations. So here is a picture from one of the online simulations for the energy skate park. This was embedded in the quiz function in Canvas, where students were provided the link, general directions, and then questions were posed and space provided for them to answer them in that quiz function. Rather than using a Word doc or Google or paper, it was embedded in a quiz for easier management. So to show you what the 2 simulators look like, this is the energy skate park. Here they're going to drag this skater onto the ramp, and they can adjust their mass as well as the friction that the skater experiences, and they are given the options to analyze a pie graph or a bar graph and see how the kinetic and potential energy changes relative to one another, how it changes based on her height as well. They even have the option to create their own ramp as well. The coaster crater is part of the Jason project of Nat Geo. They can adjust the mass of their coaster as well as the different design elements. And then they can launch their coaster to simulate a real coaster, and it graphs the amount of kinetic and potential energy the coaster experiences as it goes through their design. It will even crash or get stuck throughout it if it's not a realistic design. So students kind of get a real experience. Like here, my coaster design does not make it up the hill because it doesn't have enough kinetic energy to make it. So then they can modify and edit their design, and this kind of helps build a foundation before they go and create their models. All right. So to reflect on this project, I would definitely say that I missed a good opportunity to include another piece of technology for creating the advertisements. The next time I do this, I would find several Web 2.0 options for students to use to create their advertisements. I can also make this project more multidisciplinary by having students factor in the cost of building their coasters as a part of their pitch to the company, because that is something realistically a company would do if they're pitching an idea. Troubleshooting for future teachers: definitely make sure that your virtual simulations work on student computers. Make sure that just because they work on your computer or your home computer, make sure the students have access to them and that they work. And as well as just knowing how to use them yourself so you have experience with them. And then make sure you know how to use your LMS if you're using it to submit student work, and know how to help students submit their work, because a lot of my students don't know how to do that. All right, well, that's everything, folks. If you decide to implement my project, please leave me comments on how it went for you, or if you have any advice for other improvements. Thanks for watching.